In this class, we are discussing resonance mesomeric effect, benzene bond lengths. That is the single bond, between the carbon-carbon atom. It is having a bond length of 1.52 angstrom units. But when we are considering the double bond between the carbon-carbon atom, it is having 1.33 angstrom units. This is in the presence of cyclohexene molecule. In the cyclohexene molecules, between the two carbon atoms, it is having a bond length of 1.2 angstrom units, and the two carbon atoms bonded with double bond having bond length of 1.33 angstrom units. Now, when we considering a benzene molecule, it is having the bond length between the two carbon atoms which are having double bond. It is having a 1.42 angstrom units, which is in the intermediate between which is intermediate bond length between 1.33 and 1.52, and the single bond is also having the same value, that is double bond as well as a single bond are having a similar values. So all the bonds in the benzene molecule considered to be similar type with same bond length. Now let us consider the resonance structures of benzene. If you see the benzene molecule, one of the conical structure of the benzene molecule, as the electrons are moving, it is you are able to get a new structure. You can see here, when arrow mark is moving like this, it is forming a double bond, and this arrow mark is moving like this, and here forming a double bond. When it implies double bond is moving around the benzene ring. So the movement of the benzene ring is represented by a true structure that is called as resonance hybrid. This is the resonance hybrid. The pi electrons are referred to be conjugated. Here, one of the most important condition is the pi electrons are referred to be conjugated. That should be conjugated between alternate double bond should be there. Here, 6 pi electrons are able to flow or resonate continuously to form a around the molecular orbital. These 6 pi electrons are moving continuously around the p molecular orbitals around the 6 carbon atoms in the ring structure. This is represented as two resonating structure, which are called as canonical structures, which are identical and degenerate. Identical and having the same energy value. The flow of electrons lead to the very stable structure that is called as resonance hybrid, which is having a very less energy compared to conical structures. This is the resonance structure. Now, the resonance imparts stability to the anionic structures also. Let us discuss here. This is the molecule with minus charge, or oxygen bearing a negative charge. Here, when CH2 is replaced here in this carbon, or double bond is replaced in this carbon, in this point carbon, you will be getting a conditions like this. Here, when this carbon atom, is substituted with the CH2 group, it's the relative stability, relative difficult to form this table. It is this type of structure, that is ethoxide. This is the ethoxide molecule is less stable. Whereas if we if is having a double bond here, that is the structure like this. Here the double bond is there, which gives a resonating structure as the electrons are moving, So the negative charge is moving here, from here to here, and this oxygen is bearing the negative charge, and this gives extra stability to the molecule. Whereas here, when C, when this carbon atom is substituted with the CH2 group, which is not having resonance, so the relatively difficult to form, and this structure is relatively less stable. Whereas if this carbon is separate, substituted with the CO group, which gives a extra stability to the molecule due to the formation of resonating structures. Now, let us discuss one of the important point in the resonating structures. Whenever there is a possibility of forming a charged species which are having undergoing a resonance, then such type of charged species will be easily formed. That is, this point represents the degree of ease formation of the charged species is very easy whenever the charged species are having uh, or undergoing a resonating structures. So, for example, benzyl carbocation, which is having the benzyl carbocation, which is positively charged, have very stable due to the involvement of the resonance in its structures, in its conical structures. Now the stability of the charged species, this stability of the charged, the benzyl carbocation is having extra stable compared to aliphatic carbocations. Now let us consider the rules of resonance. The first rule is the resonance structures differ only in the position of the electrons. The position of the atoms does not change. Only the pi bonded bonded system, that is double bond, undergoes a change. That is, movement in the double bond will be observed, but there will be no change in the movement of the atoms. That is, here the electrons are moving from here, it is forming a double bond, and this double bond undergoing a cleavage and forming a negative charge. Only the movement of the electrons will be taking place, but the original atoms are intact. They are not involving in the movement. The next is the resonance structures can be interconverted by movement of electrons indicated by curly arrows. Here these two structures represents are interconverted by curly arrows. Okay, now all the structures are valid with Lewis. It should obey the Lewis structures, that is, all the resonating structures should obey the Lewis structures. Okay, an atom may become electron deficient, but on the other hand, it must never be shown with more valence electrons. That is, it can be accommodated. That is, this is very important, that an atom may become electron deficient. That is, octet electronic, the stable electronic configuration is 8, but On undergoing a cleavage, it can obtain a electron deficient species with the uh, 7 electron system or 6 electron step system. That is, 6 electron system means it in the formation of carbocation. The carbon is forming a electron deficient with 6 electrons. That type of structure, any atom with the 6 electron, that is electron deficient, is possible, but there should not be there should not be any atom, there should not be any structure in which atom is having excess number of bonds. That is, it is not possible to have pentavalent carbon. The carbon is having maximum covalency is equal to 4. That it should not have this, it should not disobey this covalency. That is, pentavalent carbon should not be possible in any of the resonating structure. Overall charge must remain same always in all the resonating structures. The each of the molecule should have overall charge should be same. This redistribution of electrons provide us with one or more resonating structures called as canonical structures. These two forms or three forms of the structures which the same or nearly same structure energy levels are called as canonical forms. Now here the benzene is having two canonical structures, and this each canonical structure contribute to the structure of benzene, which is a true structure. The true actual structure is resonance hybrid, and each of the canonical structures should contribute to the stable true hybrid structure. That is hybrid structure. That is this structure. These two forms should contribute to the resonance hybrid structure. This one. Okay. Now the resonance arrows and its physical meaning. The resonance arrows and its physical meanings. Let us discuss here. Now here, oxygen with negative charge. The negative charge is forming a double bond. Here you can see here, this negative charge is forming a double bond. Then what happens? This double bond undergoes a cleavage and it forms a structure with oxygen, a structure in which oxygen is having a negative charge. Here you can easily observe that negative charge is moving. Negative charge is moving in this structure. Oxygen with red color is having a negative charge, whereas here the oxygen with pink color is having a negative charge. This is possible with the movement of electrons. Always you have to mention the movement of lone pair of electrons. The negative charge is moving. Always the electronic movement should be there. Okay. Now, the resonance arrows show only distribution of electrons. This resonance arrows should only distribute, shows the only the movement of electrons. Okay. Thus, there are the two degenerate structures. The implication is that the even distribution of two electrons between the oxygen atoms at all the times. That is equal distribution of electrons between two canonical structures at all the times. Both the canonical structures are having the same energy here. So these two structures are represented by a resonance hybrid which is in this box. Here the bond length between the carbon oxygen in this here with pink color and the red color are having the same bond length as we have observed in the benzene molecule. Now, general structures that will display the resonance of charges and lone pair of electrons. Now you can see here always we have to consider that only the electronic movement is taking place. Electronic movement is taking place. Here let us take two examples. Here the double bond is moving towards a positive charge. Double bond means electrons are moving towards the positive charge, whereas here negative charge means negative charge lone pair of electrons are forming a double bond, and this pi bond are forming a lone pair. Here always you have to mention the movement of electronic pairs. The negative charge, the arrow represents the movement of electrons or movement of pi bond or lone pair. Here double bond is moving here, which forms a structure like this. Double bond is moving, which forms a structure like this. Here negative charge is moving, which gives a structure like this. Okay, now mesomeric effect and resonance effect or resonance effect. Now, mesomeric effect is defined as this is a permanent polarization of group through a conjugated system. Here, conjugated double bond system. Permanent polarization of a group. Here, you can see here the double bond is moving here, and oxygen is getting a negative charge, and this carbon is getting a positive charge. That is, polarization is taking place in a neutral molecule. That is, there is no external agency which is making this molecule in the form of polarized. Only the molecules are undergoing by itself, so it is called as permanent polarization of uh, molecule but with the help of conjugated double bond system. Okay, mesomeric effect can be either positive or negative. Positive means supply of electrons. Whenever the electrons are moving towards any group, then it is called as it is donating. If it is if the any group is receiving the electrons, then it is considered to be negative group. If the any group is supplying the electrons, if the any group is supplying the electrons means it is showing the plus sum effect, that is positive mesomeric effect. If the group is attracting the electronic pairs, then it is called as negative inductive effect. Okay, the plus sum effect possessing groups are a group. Here you can easily identify the plus sum effect groups. That is, whenever any species is having a atom with lone pairs, you can see here oxygen is having lone pair 2. Here epoxide is having with oxygen 2 lone pairs, and nitrogen is also having lone pair 1 lone pair. Here amines are also having lone pairs. Whenever a conjugated system is connected to a atom which is bearing lone pairs, then it uh, act as plus sum effect showing groups. Okay, plus sum effect showing group. Here oxygen is bearing lone pairs, so it shows plus sum effect. Conversely, the negative effect, that is minus some effect, the electron withdrawing effect, is observed when a electronegative uh, oxygen or nitrogen is bonded with double bond. You can see here in the CHO group, the carbon and oxygen is having a double bond. Here, ketonic group, carbon and oxygen is bonded by double bond. In cyanide group, carbon, nitrogen is bonded with the triple bond. In the NO2 group, nitrogen and oxygen bearing a double bond. Whenever there is a possibility of there is a possibility such that a key atom, the atom which is connected to the uh, conjugated system, is also connected to the uh, a highly electronegative atom such as oxygen or nitrogen with a double bond or triple bond, then it act as minus group showing negative inductive effect. Okay, here you can see CHO as C double bond O H. Here carbon oxygen is having double bond. So whenever the cleavage is taking place, the pi bond will be attracted towards the oxygen. And in the case of cyanide nitrile mol species, it is the carbon and nitrogen is having a triple bond. So whenever a double bond or triple bond undergoes a cleavage, the pi bond undergoes a cleavage, the electronic movement is towards the highly electronegative atom. So it will attract, this type of group attracts the low of double bond towards itself. So it shows a negative inductive, negative mesomeric effect. I repeat here, whenever atom or a group which is connected to a double bonded system with lone pairs is called as lone pairs, is act as positive inductive effect. Whenever it is connected with a electronegative atom with double or triple bond, then it acts as negative inductive effect. Whenever the lone pairs are there, positive inductive effect. Whenever it is connected to the double or triple bond, then it acts as, it shows a negative inductive effect. Now let us discuss some of the important aromatic resonating structures. Now first let us move with positive mesomeric effect groups, that is methoxy group. Methoxy group is electron donating group or electron releasing group. That is, here methoxy group is supplying the electron density in the benzene ring. Here the benzene atom molecule with methoxy methoxy group. Here you can see the atom is benzene ring is connected to the oxygen with which bears a lone pair of electrons. Whenever the conjugated system is connected to a atom with lone pair, then it act as electron releasing group. That is, it shows positive mesomeric effect, that is plus some effect. Now you can see here the arrow marks the positive, the lone pairs are forming a double bond, and this double bond undergoes a cleavage in this form here. When double bond involves in a pi bond formation, the electronic movement is taking place, that is positive charge is moving away from the oxygen. So oxygen gets a positive charge as the electrons are uh, contributed for the formation of pi bond. The electrons are partially lost. Because of that, oxygen gains a positive charge, and here the double bond undergoes a cleavage to the leading to the formation of negative charge on one of the carbon which is present at the ortho position. Now, this again, the negative charge is forming a double bond, and double bond undergoes a cleavage, which lead to the formation of this structure here. The para in this molecule, the oxygen which is at a carbon atom which is at the para position is having negative charge. When now whenever the electronic pairs, this negative charge is involving in the double bond, and the double bond lead to the formation of negative charge at the ortho position. In this way, you can see negative charge is moving around the benzene ring. This negative charge is moving around the benzene ring, that is double bond is forming it up 5 negative charge, and the negative charge is forming a double bond. From this we can see that the positive charges, the electron density is increased. The electron density is increased at the ortho and para positions. Electron density is increased at the ortho para position and compared to meta position. Even on the oxygen atom also, it is having a positive charge. Oxygen atom is also having a partial positive charge which repels the electrophile, so electrophiles, like what? Electrophiles are the electron liking species. So it tend to form a bond, where the electron rich carbon atom is there. So the negative charge in the all the three, by observing this resulting structure, you can see this here. Negative charge is forming at the ortho para position. Ortho, this here on the first and third structure, the negative charge at the para ortho position. This middle structure is having negative charge at the para position. Here ortho position, and here negative para position. So positive for red color represents electron rich system. So what happens? Electrophile likes electron rich system, so it undergoes a attraction, and at this position, as electron is electron deficient, and the meta positions is also electron deficient, undergoes a repulsion. So it lead to the formation of the meta plus some effect showing groups are ortho-para directing groups. It is also plus some effect showing groups are also called as ortho-para directing groups, as it enriches the electron density at ortho-para positions. So the substitution is taking place at the ortho position or para position. Now, some important aromatic resonance structures that are. Now let us discuss about the negative mesomeric effect. Now let us discuss about the negative mesomeric effect, taking example as nitro group, which is act as electron withdrawing group. Here this is the nitrobenzene. Here the benzene ring, that is conjugated system, is connected to the atom, which is in turn connected to the electronegative atom, that is oxygen with a double bond. So whenever the double bond is undergoing a cleavage, the oxygen attracts the pi bond electronic system. So nitrogen gets extra positive charge which attracts the electronic system by electronic system from the benzene ring. So it removes the electron density from the benzene ring, so it is called as negative mesomeric effect showing groups. Now you can see here double bond is undergoing a cleavage to form a negative charge on the oxygen atom which attracts the double bond towards the nitrogen to form a now double bond towards the nitrogen. You can see here this double bond is undergoing cleavage, and here the double bond is formed, and here double bond is cleaved. So the electrons are moving away, so which leads to the formation of positive charge at the ortho position. Now this positive charge attracts the near double bonded system which is near to it. So it leads to the formation of this type of structure where the positive charge is at the para position. This again, the positive charge at the para position attracts the double bond toward itself, which lead to the formation of this arrow representing attraction of double bond towards a positive charge, which lead to the formation of this structure. Here again the para position is having positive charge. So this type of resonating conical structures are possible due to the mesomeric effect. From these structures we can understand that the nitro group, that is electron withdrawing group, decreases the electron density at the ortho para positions as the positive charge is forming at the ortho para positions in the conical structure, so it decreases the electron density at ortho para positions. So electrophile, which is electron loving species, it does not get attracted at the ortho para position, which is having less electron density compared to meta position. So here the electrophile attacks at the meta position. You see the negative this blue color represents electron deficient and red color represents electron rich. So electrophile, the electron deficient, it is getting repelled with the electron deficient positions. So here getting repelled, so it is not electrophile does not get substituted at the ortho and para positions. Now you can see at the meta position compared to para position, ortho para position, the meta position is having good electron density, so electrophile is attracted at the meta position to form the meta substituted nitrobenzene.